So welcome to the third video talking about volume. So just remember from before, if you have a cross-sectional area of A, then the volume is A of x dx. Okay, so before we were having situations where we might have some sort of function, so like y equals x plus 5. And then we would have other information like that our bounds would be, say, 0 and 2. And then maybe this is disk method rather than washer method, but we would rotate it around an axis. So let's say the x-axis. And you could do this and find the volume. We did before. It might be a useful exercise to try this. But what we want to talk about today is what happens if this is no longer the x-axis. To keep it in that sort of disk method, I'm going to change this other bounds of integration. So let's say we want to revolve it around y equals negative 8. And so we're bounded between x plus 5 and y equals negative 8. What does the picture look like? Because a picture can often help. Well, I have my line somewhere up here. Here's 2. And then the line y equals negative 8 is down here. So I have this area. Or sorry, not all that. There you go. We have this area, and we want to revolve it around, not up here, but down here. So our thought process should first be, let's find what a of x is. Now we know what this distance is. Right? That's just the function itself. That's x plus 5. And we know what this distance is. Y equals negative 8, so it's from 0 down to, this is negative 8, so that's a distance of 8. So the total distance is going to be x plus 5 plus 8. Now, why could we do that? Why could we say that that was a radius? Well, think about it. When you're revolving this around, before we had our radius was our y value, but that was because the distance from our x-axis up to the top was that y, in this case, x plus 5. In this case, we want the radius, which is going to be from down here all the way to up there. So that's going to be pi x plus 13. Okay, so now, using all this information, we can compute the volume. So it's going to be this integral from 0 to 2 of pi x plus 13 quantity squared dx. I could use u sub here, x plus 13. So my du is dx because the derivative of this thing is 1. So this integral becomes pi u squared du, integrated from, plug in our little numbers into here, and you'll get 13 and 15. Okay, so then what? Well, this is going to be pi over 3u cubed, 13 to the 15. So then you plug this in. pi over 3, 15 cubed, minus pi over 3, 13 cubed. And that gives you what that area is. Which, after you do all the simplifying, should be 1178 over 3 pi. So that's how we're going to approach these other ones that are a little bit different. Approach it as, draw the picture and think about, well, what is the distance from our new axis of rotation to where the function is. So I'd just like to do 2 more examples. So what we've done so far was with a line, but as we know, a lot of times we like to take stuff with lines and move on up. In this case, we'll move on up to a parabola. So let's look at y equals x squared, with x going from 0 to 3, about y equals 2. Okay, so let's draw a picture. You have up here y equals 2. You have the parabola, crosses over at square root of 2, but it still goes all the way over the 3. And so we have to think about, well, what's our area function? Well, the distance from here to where the parabola is, well, you know the total distance all the way to the axis is 2, and the distance from where the parabola is to the axis is x squared. So you know that this distance over here is going to be what? It's going to be 2 minus x squared. Why? Well, because you need to be able to add them such that they equal 2. In other words, we want it to be such that y plus x squared equals 2. But that's for this area, which is in between 0 and square root of 2. What do we get? We get that this is going to be pi 2 minus x squared quantity squared. Okay, so that's fine. What about over here? We have all this area. Is it going to be the same or different, or, well, the way we could approach this is, and let's erase some of this here just to clean up it a little bit. Again, this distance is 2. This distance up to the function is x squared, and we want this part. So that's not going to be 2 minus x squared. Rather, that will be x squared minus 2, quantity squared. But we're squaring it, right? And we know that negative x quantity squared equals x squared. So this is pi 2 minus x squared squared. Okay, so that's easy enough. From here to here, it's pi quantity 2 minus x squared quantity squared. And from here to here, same thing. So when we make the integral, we don't have to split it up or anything. Okay, so for this volume, it's going to be, what, 0 to 3 pi 2 minus x squared squared. Or we can expand this to 0 to 3 4 minus 4x squared plus x to the fourth. Oh, and remember the dx's. So this will be pi, and then you have an x minus 4/3 x cubed plus 1/5 x to the fifth, evaluated from 0 to 3. And so the volume will be, well, you can put this in your calculator. And this will be pi 3 minus 4/3 times 3 cubed minus 1/5 times 3 to the fifth minus 0, or pulling out the calculator to do some quick computations here. Oh, apologize about that. That's a plus 1/5. So plus 3 to the fifth over 5 is going to give us 78/5 pi. And so that's the volume revolved around y equals 2. Now these were both with the sort of disk method approach. Why don't we do one that's more in that washer method style? Remember when we had our top function and bottom function? So let's look at x equals y, x equals square root of y, y equals 0, and y equals 1, about x equals -1. So first of all, notice that I gave you two functions, so this is looking like it's going to be a washer method. In addition, it's going to be, it's going to be like one of the ones we've been doing. It's not around an axis. But I'm giving you bounds of integration, meaning that this is not dx, but dy. And you could also see that because it's x equals x equals. So let's draw this thing. X equals y is a straight line through the origin. Not drawn particularly great, and I apologize, and then square root of y is just this, half parabola, and they will actually intersect at 1. And then we have our line x equals -1 is somewhere over here, and this is what we're rotating it around. So whenever we're thinking about our top and bottom functions, now we have to think about, well, it was top and bottom before because of this y-axis. Now over here, we have to think, what's our top and bottom? Just looking at it graphically, it looks like, so we have this area, and it looks like our top one is going to be this function here, which was our square root of y. But now that distance isn't just the square root of y, because you have a distance of 1 and a distance of square root of y. So now this becomes x equals 1 plus square root of y. What about the other one? You still have that distance of 1, but then you only go over by by y. So this other function becomes what? X equals 1 plus y. Now we have to think which one's on top, which one's on bottom. Graphically, like I said, it looks like this one is still going to be on top, and this one's on bottom. So our area function will be pi, and then the top one squared, minus bottom one squared. Let's do a little bit of simplifying just to make our lives easier. This is going to be 1 plus 2 square root of y plus y minus 1 plus 2y plus y squared and just clearing some space. That's going to be equal to what? Pi times, the ones cancel out. You'll get a 2 square root of y, and then minus y, and then minus y squared. Okay, so now is the point when we can look at, well, what's the volume? So let's do that computation. It's going to be from 0 to 1 of pi 2 square root of y minus y squared dy. Just going back up to this formula. Alright, so that's going to be pi. Antiderivative is going to be what? 2 over 3 halves. And then y 3 halves minus y squared over 2 minus y cubed over 3, evaluated from 0 to 1. Okay, I'm going to erase some of the problem up here so we have some space. So our volume is going to be pi, and this will be 2 times 2/3 times 1 minus 1/2 minus 1/3, and then minus, plugging in 0 for all that, you get 0. Okay, so this is pi 4/3 minus 1/2 minus 1/3, or pi over 2. So the volume of this thing is just pi over 2. And that is how we do these, is you want to think about distance from our new axis, our new whatever we're rotating around, to our function, and do all the same steps that we've been doing up to this point. So if you have any questions, just message me in Canvas or leave a comment, and I will see you all online.